Hello students, so this is Brock Skaggs. I'm going to make this video demonstration of modeling the bracket part you see on the screen right now inside of SolidWorks. And so one thing you'll notice about the bracket part, we've got a default configuration on the left hand side. We'll try to target that geometry first, and then we'll make a few changes so that it looks like the config A version on the right hand side. Just kind of skimming the title block, you can see the dimensions are in inches, and the material is 7050 T7 451. Aluminum alloy there. And so here's the overall isometric views of the parts, and then if we go to sheet 2, this is the detailed drawing of the default configuration. So we'll be spending quite a bit of time looking at this one first. Usual front, top, and right views, as well as a detail kind of showing the handle-ish geometry there. And then in config A, we have the changes. So in config A, you can see we're adding a 1/4 inch thick rib, as well as the extrude cut going through the portion of the part there. And so with that being said, let's go ahead and hop right into the modeling portion of this. And so I'm just going to get a new part template going in SolidWorks. IPS unit system is good. As far as the initial base feature here, one thing to take note of is the orientation and origin placement. So origin is right here. Looks like it's on the very front surface there. If you were to zoom in, you should be able to see the little gray asterisk there. You can also see it's on the front surface here from the ISO. And the orientation is going to end up looking something like this in the isometric view. So what I'm going to go ahead and start off with is the handle portion here. And so I'll get on the front plane, I'll draw kind of the semicircle here. I got the two horizontal lines, and I'll truncate it at some point off here to the right hand side, and I'll go ahead and extrude that portion to get us started. And so IPS units is good. Let's go ahead and apply material. And so edit the material, and it's an aluminum alloy here. So scroll down to 7050 T7 451, I believe. So apply and close. Now I'll get on the front plane and start making my sketch entities. And so I've got a circular hole with a diameter of 1, centered right at the origin. So I'll go ahead and start off with it. And then we've got a large arc with a radius of 1 that's concentric with it. So I'll start off with that circle there. And then you can see the 2.5 inches here. And so I'm just going to draw some lines, catching right at the very top and to the bottom of the circle, and draw my rectangle here. At this point, I don't need the right hand side of the circle, so I trim it off. And you can see the radius is 1 there. So far so good. As far as that length dimension, let's go ahead and make it the 2.5 here. Okay, arrived at the nice fully defined sketch. We'll extrude that back a depth of 1. And we've got our base feature. Here I'll go ahead and put in the extrude cut as well. You can see from the top view you've got a very similar sketch you'll make, except for it's going to be extrude cutted. And so let's go ahead and do that. Go get it and get on the top plane here. You've got a circle and 2 straight line segments terminating at this edge. So I'll go ahead and run those first. See how that line is now coincident with that far left edge, but not this one. And so I could try to select that edge, which I'm not having a whole lot of luck with, so instead I'll just make these lines equal, and that should get the same effect. I'll go ahead and trim this segment off, and one thing I'm going to have to do is center this thing, and so I'm going to see if I can snap to a midpoint. It doesn't appear to be going so well, and so we'll go ahead and come over here. 0.625 is this dimension, 2 inches is the length. And so now at this point this thing's going to slide back and forth, and we need a way to eliminate that sliding action. And so one thing we could do is possibly catch the midpoint here Notice I've got the midpoint of that edge, which runs the entire length. I'll draw a line that goes from that midpoint to the center point of the arc, as you can see, and we'll just say, let's make that vertical, or horizontal, excuse me. And then I'll make it construction in order for it to not be considered in the cut extrude. And at this point I am fully defined. Since I closed off my boundary here, I should have a nice enclosed area to make my cut extrude. One thing that's happening right here that I'd like to point out is notice that the sketch 2 here, has a minus sign next to it, indicating it is under constrained. But down in the bottom right hand corner of the graphics area, you can say it says fully defined there. And so here it's kind of conflicting messages SolidWorks is sending you. On the tree it's saying, hey, you're underdefined, but down here in the lower right it's saying fully defined. I believe this part is fully defined. Everything is black here. And so when we exit the sketch, I believe it will adjust the update here on the sketch 2. So let's exit the sketch. Notice the minus sign goes away, reflecting it is fully defined. And of course now I can use it in the cut extrude. And I'll go through both directions in order to complete the part there. And so far so good. So now let's go ahead and work on the real body part of this bracket, so this portion right in here. And so if we look at the front view here, you can see it extends above and below the part. Overall depth is 2.5, so in order to achieve this, I'll make my sketch on the top plane and then go a mid-plane extrusion in order to get that geometry. And so again, sketching on the top plane. Go normal to the plane here. And you can see we went to 2.5 for that first depth, but the geometry here for the body part of the bracket goes back to 1.75 from here. And so I'm just going to go ahead and draw a line segment in here to get me started. And it's 1.75 from the origin, which is looking good. And so now I can go ahead and sketch out the rest of the body bracket. So we've got a horizontal line here. We go down at an angle. A vertical line there. Comes over here. And let's see, that 2.5 dimension, which is to this edge right here, I believe matches right up with that line. So that needs to be a vertical line segment here. And then finally one last line to connect those. So that's the overall shape. Now to size it with dimensions. 30 degrees is the angle. So smart dimension there. 2.75 is the overall height here. 1.25 is this dimension here. And what about the length? You can see 7 all the way from the origin to the far right end. So with those dimensions, we have arrived at our fully defined sketch. Now I'm going to go ahead and put a sketch fillet in there. From the detail here, you can see it's 0.5. So I'll go sketch fillet, adjust the radius value. And go 0.5 there. In order to arrive at our geometry. And now we go mid-plane extrude to 2.5. So I'll boss extrude here, mid-plane, and we said 2.5, which you can see extends us a little bit above and a little bit below our existing geometry. So doing good work so far. Now we've got this cut here. It's very similar to the geometries we were drawing before, just a half circle and 2 straight lines. And so I'll go ahead and grab the front face here. It's going to be a through-wall cut. And start my sketching. And so again, I just start off with a circle, draw my horizontal lines, snapping to the boundary there. And then I can also trim entities the inner portion of the circle itself there. So at this point, it is centered again, a quarter here, and it should be a quarter down here below. And so instead of putting that hard dimension in here, I'm going to use, again, construction geometry in order to snap it to the midpoint of that edge. As you can see, we'll make that a construction, and now we know that this thing will always be centered on this face. As far as the length, you can see 3.25. There's this dimension here from the drawing. 2 inches, the overall height here. And again, just using the dimensions we have in the drawing gets us to a fully defined sketch. So now we'll go straight into the extrude cut and through all as usual to arrive at our existing geometry. So looking good. I think we are missing a few chamfers here, as well as a couple fillets as well. You can see right here and right here from the front view that you have 1/8 inch fillets in there. And so I'll go fillet 125 here and go ahead and place those on those hard edges. And then the chamfers. If I kind of look at the front view, you see it's chamfered here and also on the bottom. The chamfer is 0.25 by 45 degrees from the note in the bottom right. And so under fillet, of course, is chamfer 0.250, and that would be placed here and down below. And just checking the drawing, I believe we have arrived at our desired geometry here. And so this should be the default configuration. And so let's check mass properties real quick. 1.21 pounds looks good. 3.06 for the x coordinate, 0 for the y coordinate, and 0.14 for the z coordinate. So yes, those mass properties do match up with what I was expecting. And so now let's move on to config A. And so again, to compress this all into one part, I'll go ahead and create a new configuration called config A. It's fine to link the display states. And we've got two things to do. We've got to add the rib and also make the extrude cut here. And so adding the rib, we'll actually use the rib feature to do that. It'll be very convenient for us. And so now that I'm on config A, I'm going to get on the top plane and create the rib feature. You can see the rib's right in the middle with respect to the height of the part. And so I'll come normal to. It's control 8. And with the rib feature, all I've got to do is draw a line, and I don't have to enclose an area. So you'll see that happen here. 1.25 is the vertical dimension for this line. The horizontal dimension is 1.5. And then the thickness is 1/4. And so here I can go into features, and notice now I have rib. And so here all I've done in this sketch is just draw the single line, and so then I can come in with rib. You can see the arrow kind of pointing in the direction it's going to pull the line segment here. Here we need to flip it so it goes back toward the part. This thickness allows you to place it above the part, above the line, midline, or below the line. So here we want the middle version. And then for thickness we want 0.25 instead of the default 0.1. 250. So with that, I believe we're good. And so as you can see, it creates the nice rib feature for us. Very quick and easy. So one thing you will notice though is the rib has been rounded. You can see that right here in the isometric. And that's actually a full round fillet is what that is. And so that's a special fillet inside of SolidWorks, but you just access it through the usual fillet command. Full round fillet is right here on the far right. And instead of specifying a radius value, you specify 3 faces. And so you specify, say, one face here, the middle face, and the bottom face in this case. And you can see how it rounds it through there, which is exactly what I'm looking at. And that looks very good. Nice smooth rounded corner there. So next we've got the extrude cut here. 1/4 inch typical. And so 1/4 inch here, here, here. And this 1/4 inch on the left hand side is actually to the edge where that chamfer is at. And 0.5 typical rounds inside of this extrude cut. And so for that I'm just going to hop on this very top face, create a sketch here. And the first thing I'm going to do is use my offset. We said there's a 1/4 inch typical offset value here, and I can go ahead and start selecting some edges here to offset with. Here you can see it went all the way out, so I'll just reverse to go in. And then I'm also going to draw one vertical line here to define this offset with respect to the chamfer. And so again, I can trim off my excess here. Smart dimension here for that width, and I've now created the basis for that cut extrude. Now I just need to come back in. I'll go to sketch fillet. 0.5 radius is the correct value, and then just come in here and basically smooth off, round off all these sharp edges. Then check it once more against the drawing. Looks pretty good. And I'll go ahead and extrude cut through all here to complete the part. And at this point, putting an isometric view, I believe that should get us to our desired geometry there. And so looking good at this point. Now I'll go ahead and check mass properties just to confirm. 0.87 pounds is good, 2.43 inches, 0 inches, and negative 0.02 for the mass properties. And so it looks like we have successfully made it to the configuration A of the part. And so as always, thank you for watching the video, and hope this helps you develop your SolidWorks modeling skills.